The principal purpose of a power plant is to generate electricity for use by consumers in a number of different service areas. These consumers may include industrial, residential, and commercial customers in a variety of geographic locations. The transmission part of a transmission and distribution system supplies electricity to substations in individual service areas. The job of the distribution part of a T&D system is to take this electricity and supply it to individual consumers at a voltage they can use. Doing this job properly requires the use of a variety of electrical devices and an intricate system of distribution lines. That's what we'll be looking at in this program. The purpose of this program is to give you a basic understanding of the components that make up a typical distribution system. We'll show you how to recognize individual components and give you a basic explanation of the jobs they perform. In later programs, we'll look at specific components and how they work in greater detail. Right now, we'll give you an overview of a typical distribution system. Let's begin by defining a distribution system. A distribution system includes all of the components in a T&D system that allow power to flow from a substation to a consumer. Transmission lines supply electricity to a substation at a transmission voltage. The substation is the beginning of a distribution system and is usually centrally located in the area that it serves. Inside of the substation, the transmission voltage is stepped down to distribution voltage by a substation transformer. Electricity at distribution voltage, also called primary voltage, is supplied from the substation to the service area by distribution lines. These lines may be located overhead on utility poles or buried underground, which is very common in residential areas. Located along distribution lines are electrical devices. These include voltage regulators, capacitors, and distribution transformers. A voltage regulator maintains primary distribution voltage within a specified range of acceptable values. Capacitors, which are generally arranged in banks, are used to increase the overall efficiency of the distribution system. Distribution transformers step down distribution voltage to utilization or secondary voltage, which is the voltage of the electricity supplied to individual consumers by service drops. Secondary voltage varies depending on the requirements of specific consumers. An industrial plant, for example, may have different voltage requirements than a residential consumer. In a distribution system, you may also find a number of protective devices such as circuit breakers, fuses, reclosers, sectionalizers, and surge arresters. These devices protect both the distribution system and its components from damage due to faults, voltage surges, and natural hazards such as lightning. In addition to protecting a distribution system, some of these devices also make it possible to isolate specific sections of a system for repairs while maintaining service to the majority of the customers in a service area. This process is called sectionalizing, and we'll look at some basic examples of how it's done later in this program. Right now, let's review some of the things we've covered so far. First of all, we defined a distribution system as all of the components in a T&D system that allow power to flow from a substation to a consumer. Some of the components that we've seen are transformers, voltage regulators, capacitors, and various protective devices. We've also told you that in a typical distribution system, electricity is supplied at different voltages. Typically, these voltages are classified as primary, or distribution voltage, and secondary, or utilization voltage. A distribution system must be extremely flexible so that it can supply a variety of customers in a variety of areas with service. The components we've seen can be mounted on poles or buried underground. We'll look at examples of both overhead and underground components throughout this program. In the next part of this program, we'll look at distribution transformers, what they look like, and how they work.